Okay, so do you have at least one ace? And then do you have more than one? So we need to calculate what's the probability that somebody who has at least one ace has more than one. So how do you think we're going to do that?
Well, you could write their hand as a representation, like as a probability. So you could represent their hand with one ace, like in the lefternmost slot.
Okay.
And then have 12 blank slots, which, because the only information is, they have at least one ace.
Uh-huh.
And then...
Alright, so we could put one ace here and then 12 cards.
And then for those 12 cards, you could then calculate the probability of having another ace in those buckets.
Okay.
So excluding the one ace, so for the second bucket.
Yeah, it's tricky though because when we just have one ace, we don't know which ace it is or anything like that.
Yeah, I mean which ace it would be, it wouldn't matter in this case.
Well, we should be careful because if we put the ace of, let's say we put the ace of hearts here, and then later in these 12 we select the ace of diamonds.
Yep.
And then later on we put the ace of diamonds here. Sorry about not being able to draw through the treadmill and select the ace of hearts. We've accidentally duplicated our thing. But you're on the right track here of how we should be thinking about this.
Well, maybe instead of just it being forced, you could have 4 choices for the ace. So we're gonna multiply and I guess that wouldn't really work out.
Yeah, how can I make this list unique so I never get any duplicates?
We'll just maybe forcing one ace to be here, like forcing the ace of spades.
Okay, I could do it with the ace of spades. For sure. And then what would you start counting next?
Well, for like the second slot, you'd count the probability that you get another ace that isn't the ace of spades.
Yeah. So can you see that's going to get complicated?
Yeah.
Yeah. So you're on the right track. I want to break it down into very simple cases where I can count and be sure I'm never duplicating. So what are some cases? So I know I have at least one ace.
Well, maybe one ace, 2 aces, 3 aces, or 4 aces.
There you go. So 1 ace, 2 ace, 3 ace, 4 ace. Okay, now I know I'm never going to duplicate. Why?
Because I guess the numbers of aces are forced. So if you pick like the ace of hearts to go in your first slot, that's never going to be a duplicated case.
Okay, so how many 13 hard card hands are there where I pick one ace?
You should have one ace forced. That would be 4 choices for that, and then
Yep.
48 or times 48 times 47 times 46. We're just choosing 12 cards out of 48. 12 choose 48, or 48 choose 12.
Yeah, 48 choose 12. Okay, so I got 4 times 48 choose 12 that have exactly one ace. Okay, how many have exactly 2?
Well, 4 times 3. So you have just 4 choose 2.
Yeah, what does 4 choose 2?
Choosing the 2 aces.
No, but what is the value of 4 choose 2?
6.
6, yeah, 6 times
47, or no, 48 choose 11.
48 choose 11, very good. 3 aces.
And then that would be 4 choose 3. I think that would be 6 as well. Or no, only 4.
Okay, why? Why does 4 choose 3?
You're essentially picking the ace that you leave out.
Yeah, good. So that's 4 times what?
48 choose 10.
48 choose 10.
And then
4 aces.
we have 1 choice, and 48 choose 9.
Choose 9. Yeah, so obviously we are not able to calculate these numbers in our head, but if I call this A, B, C, D, what is the probability that if I say yes to having at least 1 ace, that I have more than 1 ace?
Well, that is for 3 out of the 4 choices, B, C, and D. So, yeah, it's B, C, and D.
Okay, so what is the probability? What calculation do I need to do? We're not going to do the calculation, but I'm going to just simplify it with the A's, B's, C's, and D's. So I say yes to having at least 1 ace, and now I'm trying to calculate the probability of having more than 1 ace.
Well, it would be these amounts divided by the total number of cases.
That's right. So what's the total number of cases? In terms of A, B, C, and D?
A plus B plus C plus D.
A plus B plus C plus D. And what's the cases where I have more than 1 ace?
B plus C plus D.
Good. B plus C plus D. So we got to figure out what that is, but we can put that into a computer, or we'll look at the actual answer after we do the next calculation.
Okay.
But this is correct. So for this counting problem, the best, well, maybe not the best, I don't know, but certainly one way to do it is to break it into cases. How many have exactly 1 ace? How many have exactly 2, exactly 3, exactly 4? Find out how many of those have more than 1.
Yeah.
Okay?
All right.
All right, so let's do the next the other case, the ace of spades.